All right, hello and welcome. Today we're talking about classroom exercises 9 and 10, and now we don't want to be like this guy over here. We want to take good care of our brains. The mind, the human brain is a pretty amazing thing. And even though he's not human, I assume his brain's pretty good. He's just throwing it away. Okay, so we want to use that brain today. We don't want to throw it away, and we want to get this. We can do this here. And I haven't done this one yet. Maybe this one was tricky. It may have been sometimes late in the classroom exercises. They kind of throw some stuff and like, why are they asking this one here? Let's try to assess this here down together. Okay, finish simplifying the problem in two ways shown. So it looks like this top one here is saying that I got to simplify 7 over 50, the root of 7 over 50, that is. So here, the problem with this is that you have 50 in the denominator, and the square root gets applied to the whole fraction, and that's no good because we can't have an irrational denominator, okay? So we need to do something called rationalize the denominator, which I'm assuming you know about, right? From watching the videos, we need to rationalize the denominator. So they're doing it two ways. This first way, it looks like they said, hey, you know what? I have a denominator of 50 down there. I can just multiply this 7 over 50, root 7 over 50. I can multiply it by 1, okay, right? Multiply it by 1, but we want to multiply by 1, my y there, by 1 in disguise, okay? In disguise, I call it. And you can barely read my handwriting right there. I just wrote multiply by 1 in disguise. So what they decided to do is multiply by 50 over 50. Okay, so what we know is that 50 over 50, that equals 1. And what we know from the identity property of multiplication, if you multiply any quantity by 1, the value of that quantity doesn't change. So it's not like this expression would become something different magically. It's just going to be an equivalent expression at the end of the day here. So they said, hey, you know what? Because my denominator is 50, I can multiply by root 50 over 50. And then if I do it, it looks like I get like 350 in the numerator. Well, let's see. What do they do here? 7 times by 2 times by 25. What are they doing? That's crazy. That's wild. I think the idea of this, the reason why they wanted to multiply, specifically, they wanted to get this bottom, this denominator multiplied by 50. So they multiply by 50 over 50. So the key thing is that this here, right, we take the square root of that, that's going to equal 50, right? That's going to equal 50. So it's a way of breaking out the denominator. So now you have the denominator rationalized here because all you got to do, right? All you got to do to rationalize the denominator is multiply by 1, right? But it's the denominator over the denominator, the original one you have there. And then, right, you have the denominator times itself underneath the square root symbol. So that's just going to be the denominator at the end of the day, right? We can 50 times 50 is 50 squared. Take the square root of it is 50. Okay, hopefully that makes sense. I'm not sure if it does. So they do that here, right? They broke out the denominator here just by multiplying by 50 over 50. Then they're left with this garbage here, right? 7 times by 50. And it looks like what they're doing is they're breaking this apart right here, 50, because they know that 50 is a composite number. And one of the ways we can arrange that composite number is by 2 times by 25. So they broke that out and they put that here. The reason why that's significant is because 25, you can take the square root of that part, right, of that factor of this whole thing. So you can factor out that 5. So at this point here, right, what you do logically if you're trying to not just rationalize the denominator, which you did at the beginning here, or they did at the beginning here, you want to simplify the square root. You can simplify the square root more because you can take that square root of 25, so you can pull the 5 out. So this is going to be 5 over, and you just need a lot more space here. This is kind of messy. We'll have, this is 5. I think the next step of this that they would go to is honestly this, 5 over 50. And then that would be root 7 times 2. Okay, now we notice here that 5 over 50. Okay, how did we get there again too? Well, we had 1 over 50 here, and then we had a square root of 25 here. Square root of 25 is 5, so we can pull that 5 out. And this would just be 1 over 50 times by 5, which is the same thing as 5 over 50. Okay, we can't really do much about the 7 times 2. Both of those are prime numbers here. We can't factor them anymore. So, and they're not perfect squares. Obviously, if they're a prime number, they're not a perfect square. So anyways, we might as well multiply these back together and arrive at our final answer, which is going to be, well, it's not, we don't even, actually, we will have a fraction here at the end of the answer. So eventually, right, we're going to have root 14 at the end of our answer here. But here, 5 over 50, that's a fraction you can reduce, right? 5 over 50, 5 goes into both of those. Goes into 5 one time, goes into 50 10 times. So I think this is the answer they're looking for here. 1/10 root 14. All right, Messi, I don't know. He saw it different ways. Maybe he learned something from me, but hear me talk through it a little bit here. All right, alternatively, here's another way that they noticed you can do this here. They said, hey, this is 50 right now in my denominator. I have to rationalize this denominator. So basically, another way you can rationalize denominators is that if you can find a way you can change that denominator, again, by multiplying by 1, to get it into, make it become a perfect square, okay? Because what you know about 100 is that the square root of 100 equals 10, right? Equals 10. So this is just another way that you could have rationalized the denominator, which might have been faster for some people. Again, we're just giving you tips, different directions you can take it. There's not just one way we want to tell you. Like, we'll tell you one way and be like, this is the way that I do it, but you eventually have to find your way. And this is a way that can be faster for some people. So here, if you have root 7 over 50, you got to rationalize the denominator. An easy way, I mean, you could have, I guess, if you divided both by 2, this would have been 25, but this would have been 3.5. That's a mistake. That wouldn't be helpful there. So if you multiply the top by 2, bottom by 2, again, you're multiplying by 1 in disguise. Okay, so 7 times 2 is 14. And then now, right, because you multiply by 2 over 2, it's this 50 times 2. We got 100 in the denominator. Take the square root, and that's 10. And our answer here is going to be root 14 over 10. Which matches up with what you had over here, okay, right? 1 over 10 times root 14 is the same thing, right? Because that would be root 14 over 1, and 1 times root 14 is root 14, and 10 times 1 is 10, so root 14 over 10 is the simplified way, okay? So I'm kind of curious how this is going to look on the Jamboard tomorrow. I guess people will be like, well, what was the point of this? And that's part of the reason why I'm happy that we have this video now, so I can be like, just watch this video. You don't really need to think about this one too hard, right? You can be more like this guy. You're more like, where's the guy? Where's the guy? There he is. You can be like this guy when it comes to problems like this. That's fine. This is unnecessary, this question. All right, number 10 here. Finish simplifying 2 over root 8 in the two ways shown. Okay, so again, we want to rationalize our denominator. We can't divide 2 root 8 ways because that makes no sense. Root 8 is an irrational number. It's non-repeating, non-terminating. It goes on forever. It would be about 2.7 or something like that. Anyways, it's not a good number to divide because you never divide into 2 cleanly if your number keeps going forever. Okay, so they're doing it a few ways. This is the way that I would recommend. Okay, this is this right here. This is yes. I like this way, right? Because it's just look at that denominator, multiply by, right, 1 over 1, not 1 over 1, but like this is a 1, right? The same thing over itself, so root 8 over root 8. And so now we're going to rationalize it. So of course you're introducing a root in a denominator, but the whole point of that is I want to multiply times that other root to cancel the root out. So you're working your way into an acceptable answer in this particular one here. So 2 over root 8, this is how I would simplify it. They're going to show you another way, which might be easier for some people in a second. 2 over root 8, root 8 over root 8, you're allowed to do it. Identity property multiplication, you can multiply by 1. It's not going to change the expression's value. So we have 2 root 8 over 8, right? Because remember that this, right, root 8 times by root 8 equals 8. 2 times root 8 can't combine that. You just have 2 root 8s here. Okay, now we have this where maybe they have 2 different spots down. So they're like, okay, how can we finish simplifying it? See if we can figure it out. We're going to end up with, right, 2 over, well, how do they expect you to have? Why are there 2 spots here? I don't know. 2 over root 8 times by root 8. It'd be the same thing here too. So if you just simplify this, 2 over 8 is going to be 1/4. So our answer here is 8 over 4. Sorry, root 8 over 4. And that's as simplified as we can get. I don't really know why they have 2 different spots there. All right, last one here. So this is just another way of doing it is, hey, check it out. Okay, right? We're trying to simplify 2 over root 8. And the idea is, right, what can we multiply by to make this a perfect square? Right? What can we multiply to make this a perfect square? And the reason why you can ask that is because if you have a perfect square, you can rationalize it because you can actually take the square root and then you have a rational number here, right? That's what this is kind of getting at here. So if I have root 8 in the denominator, I might as well just multiply by root 2 because that can make my denominator root 16. And then root 16 equals 4, okay? So in order to change this from root 8 to root 16, I would need to multiply by root 2. So that means I need to multiply the numerator by root 2 so I can multiply by a 1. Again, we don't want to change our given expression. We want to keep it the same. And this keeps it the same, right? This keeps it the same. So here, 2 times root 2 is 2 root 2. Root 8 times root 2 is 16. Perfect. Square root of 16 is 4. We can do that. Can we take the square root of 2? No, we can't. We know that from earlier. Then so this is going to have 2 root 2 over 4. Okay, but what I can do, if I have 2 root 2s and I'm splitting it 4 ways, that means everybody gets a half a root 2. And there's our answer. So I got this one wrong. How did I get this one wrong? Jeez. Let's see. Oh, you know what? I did. I actually didn't finish. I didn't finish simplifying this one here. Got a little carried away. Sometimes when I'm explaining, I'm trying to make excuses. I just made a mistake. I didn't think it all the way through. So because this is root 8 right here, I can simplify this because root 8 does have perfect squares that go into root 8. So check it out here, right? Root 8 is the same thing as 4 times 2, right? Or 8 is the same thing as 4 times 2. So root 8 equals the same thing as root 4 times 2. That's something that I can simplify, right? That's something that I can simplify. I can take the square root of 4. That's going to be 2. And I'm left with 2 root 2 over 4. 2 over 4, well, that's just 1/2. So this ends up equaling root 2 over 2. And we got it there. All right. So anyways, hopefully that made enough sense. Hopefully, there we go. That guy. You're not wanting to do that right now, but thank you for getting your homework done. Nice and early in the day. Take care. Bye.